Okay, this is a quick video just explaining how you can use Excel to work out means and standard deviations from your experimental data, and also to how to correctly plot them on a graph when you have calculated them. This is data from an experiment looking at the effect of temperature on cell membranes. It's a classic experiment where you take cores of beetroot and place them in boiling tubes set at a range of temperatures, and then you look at the amount of pigment that leaks out of the beetroot cells by measuring the percentage transmission using a colorimeter. Here is the data that's been collected. Okay, so we've got 7 lots of data, 7 repeats, which makes it a very reliable experiment. Now, we can work out the mean very easily using Excel if we look at this button at the top called Auto Sum. If you click on the little arrow beside it, there is an option called Average. When I click on that, it automatically tries to work out the average for this entire row of data. Now, I don't want to include the 10 degrees C because that's not a result. That's part of the independent variable. Now, I can just drag the box and make it smaller so that it's only selecting the data that I want to collect an average of. And if I just hit return on the keyboard, I get my average of that data. Now I can copy that down very easily for the whole column by selecting that cell and then double clicking that bottom right corner when I see that cross, and it will just copy that information down for the whole column. Now for standard deviation, okay, I'm going to need to use a formula, and the easiest way to do a formula is to type equals on the keyboard. That prompts that the cell's going to do a formula. I then type S and T on the keyboard, and it comes up with some options. And I'm going to choose stdev.s, which stands for standard deviation. Okay, double click it, and it then looks like this. And it will ask you then to select the data you want. So you just drag over those 7 sets of data again there, and again just press return on the keyboard, and it works it out for that, the standard deviation for those 7 results. Now I can copy that whole column down by again selecting the cell and then double clicking at the bottom right hand corner when I get that cross shape, and then I've got all the data. But it is in too many decimal points at the moment. Okay, I've got 4 or 5 decimal points here, which is way too many compared with the rest of the data. So in order to change that, I can right click on when I select all that data in that column. Okay, and I'm going to choose Format Cells when I right click, and it will come up with this box, and I'm going to click on the number section and reduce the decimal places down to 1. Click OK, and now you can see that the standard deviation is all to 1 decimal point. Okay, so now I've got my means, I can plot them on a graph. Okay, along the x-axis, I have got my temperature, which is my independent variable, the thing that I am changing, and on the y-axis, I've got my percentage transmission, which is my dependent variable, which is the thing that I am measuring. Okay, you need a suitable title. Okay, for the graph, a descriptive title describing exactly what this graph is showing. You need the axes labeled correctly with the correct units and a suitable scale for each side. Plot the points as little x's, okay? And now we can think about plotting the standard deviation. Now the standard deviation is trying to show how the results are spread out, how far they are spread for each temperature. So were they all really similar? So at 10 degrees C, were they all around 70, very close, 69, 68, 67, very close, or were they very spread out and you had some down at 20 and some up at 100, but it still averaged out at 70? So we can get a good idea of the spread of the data. Now the way to represent that, the standard deviation on the graph, is to draw an error bar. Okay, and we draw the bar using a straight line and a ruler, and for each temperature you're going to draw an error bar showing the standard deviation above the point and the standard deviation, one standard deviation measurement below the point. So if the standard deviation was 15, you would go up 15 on the scale to draw the top half of the bar and down 15 on the bottom half. Okay, and you just do that for each of your results. This is not the exact data. I'm not looking back at the table. I'm just showing you what your graph would maybe look like once you've drawn some standard deviations. And that gives us the mean result and also an idea of the spread of the data.